Hey guys, what's up? This is your friend and tutor Manas, and it's going to be yet another session in this lecture series on engineering mechanics. Today, we're going to be taking up one more problem on dynamics, and here it is. So first of all, I would suggest all of you to pause the video right now and go through this description, because once you've gone through the description, it would be very beneficial for you to understand what this arrangement is all about. Okay, now I'm assuming that you've read the description. So let me explain you what this is all about. And essentially there are three blocks. Okay, block A and block C are on an incline and block B is suspended. All right, now these three blocks, the weights of these three blocks have been given to us: 1800 and 400. 1800 and this is 400. Okay, so what's next? The stuff that we need to determine is the tension along this string. Okay, and apart from that, we also need to work out the accelerations separately of these three blocks, of block A, block B and block C. But for all that to happen, we first need to work out whether this block A is moving downwards or upwards. Okay, now you can clearly see that this block A is directly connected to this block C with the help of this string. All right, so one thing that we can successfully say is that if this block A goes down the plane, this block C moves up the plane and vice versa. Okay, so the first thing is to determine the direction of A, or direction of motion of A. How can that be done? Here we go. So initially guys, we're going to be assuming that everything is static, nothing moves whatsoever. So block B's weight will obviously act in the downward sense, and it has been given as 800 newtons. So here it's 800 newtons. So if you consider this pulley, okay, to be the object, it is pulled by a force of 800 newtons, and here we have two strings, something like this. Let me show you. Here this 800 newtons will be divided, so this is going to be 400 newtons and this is also going to be equal to 400 newtons. So you can essentially say, since everything is in the case, or since everything is in the static equilibrium, the tension developed in the string will be, it's not 800, rather let me rub this, that's 400 precisely, that's 400, and here also it's gonna be 400 newtons. So what we'll do is we'll carry out an analysis for block A. Now this is block A. Well, obviously the weight is going to act in the downward direction. How much is the weight of block A? It's 1000 newtons. So let me just write over here 1000 newtons. Here the angle will be theta. So how much is theta? It's tan inverse 3/4. You just need to do this calculation. Theta is going to work out approximately as 36.87 degrees. Okay, that's 36.87 degrees. So the cos component will be along this direction. So this is going to be 1000 cos 36.87, and over here we'll have the sine component. This is going to be 1000 sine 36.87. Let me check out how much this value is. 1000 cos 36.87, and this is working out as 800. Okay, so this is working out as 800 newtons, and if you do this calculation, 1000 sine 36.87, this is going to work out as 600 newtons. Well, that's it. Okay, so the tension over here is 400, and this is the sine component of the weight. Now again guys, there is a dilemma. We don't know where the friction is acting. So if the block is going downwards, the friction will go upwards. If the block is moving upwards, the friction will go down the plane. Okay, now I'm going to consider two cases. Case 1, I'll assume friction at block A towards the left hand side, and in case 2, we'll assume friction on block A again to be towards the right hand side. So let me just make a scale over here, make a dot, bigger dot. So this is the left hand side portion and this is the right hand side portion. We're going to take into account all the forces acting on the LHS, and we're going to take into account all the forces acting on the RHS. If LHS is more than RHS, then we'll say that block A moves downhill. And if RHS is more than LHS, we'll say that the block moves uphill or up the plane, right? So first of all, we're going to assume that friction is along this direction, this way, in the direction of this 600 Newton force. So LHS in that sense will be equal to 600 plus friction. Let's say friction is acting along this direction. But how much is its value? Well, that has to be worked out. Okay, so friction is essentially a product of coefficient of friction, or friction force is a product of coefficient of friction and the normal. So the normal will be somewhere here. Okay, for block A, let's say the normal will be represented by NA. You just try to do this, NA will be equal to 800. So essentially what needs to be done is friction, coefficient of friction is 0.2. 0.2 has to be multiplied with this 800. And you just do this calculation, 800 multiplied by 0.2, this is going to work out as 160. So the magnitude of friction acting on block A is 160 newtons. That's it. So 600 plus 160, this is going to work out as 760 newtons onto the LHS. Let's work out the magnitude of forces acting on the right hand side. Let's see how much it is. So there is only one force acting along this direction, that is 400 newtons. So you can clearly see LHS is greater than RHS. Then you can confidently say if this is the plane, inclined plane, then the object will move along this direction, okay, with an acceleration of say AA. That's it. So if this is going to go downhill, this block C will go uphill this way, right? Now let's check this. Okay, now let's take friction or frictional force towards the right hand side. And in that case, LHS will have only one force, that is this 600 Newton force. And RHS already has this 400 Newton force. So 400 plus what? Where is the friction force? Friction force is how much? I wrote it somewhere. Yes, this is 160. That's 160. If you do this calculation, this is going to be 560 newtons. Now clearly you can see that again LHS is more than RHS, which again clearly is an indication that the block A is going to go downhill, okay, towards the left hand side, downhill. So now we know the direction of A. So if A travels downhill, let's say with an acceleration AA, then C is going to travel uphill again with an acceleration of AC, right? So that's for sure. Now since both of them are connected at the two ends of a single string, which is passing over three different pulleys. Anyways, but there is a confusion. What about block B? We cannot make a judgment as to whether block B is going to go downwards or upwards. Well, that has to be worked out, or some kind of an assumption has to be taken into account. Okay, so don't worry. Acceleration relation between blocks A and B and C. So when you speak of block A, it's moving downhill. When you speak of block C, it's moving uphill this way. And when you speak of block B, we have to take some sort of assumption, right? We don't know whether it's going to go upwards or downwards. That has to be worked out. So let's just assume that B is moving downwards. What will happen? Well, let's see. Now let's try to work out this relationship between the accelerations of blocks A, B and C. Okay. Now guys, watch this carefully. Okay. Let's say this is X. Let's say this over here is Y, and let's say this is Z. So if we were to calculate the total length of the string, this is going to be equal to X plus Y plus Y plus Z. So essentially the total length of the string L is equal to X plus 2Y plus Z. You just differentiate this. dl over dt with respect to time obviously is equal to dx over dt plus 2 times of dy over dt, okay, plus dz over dt. Now based on this, which block is going downwards and which block is going upwards We'll try to work out where the length of string is increasing and where the length of string is decreasing. Wherever it's decreasing, it's a negative velocity. Wherever it is increasing, it's a positive velocity. Okay. Now guys, watch carefully. This A is moving down the plane, right? With an acceleration of AA. Okay. In that process, this portion of the string or this portion of the string's length will increase slightly, gradually, right? So that's a positive rate of change. And rate of change of displacement, you know very well, dx over dt is nothing but the velocity. So if this length of the string is increasing, you have to take a positive velocity. If it is decreasing, you have to take negative velocity. That's it. So this is what we call positive change and negative change, right? So dx over dt is equal to v for block A. That's it. So what about this dy over dt? Okay. Now, if this block B is going to move in the downward direction, this string length from here to here will obviously increase, right? So again, it's a positive rate of change. So again, a positive sign plus 2 times of velocity B. What about this Z? So this is going to go downwards. This is going to go upwards. In that process, this string length will decrease gradually. Again, the rate of change here, it's negative because it is decreasing. Hence, we have to put a negative sign over here, minus VC, and we know very well this L is going to remain constant. So there is going to be no change. Rate of change is 0, absolutely. That's why we say that the derivative of a constant is absolutely 0. So we have this relationship VA plus 2VB minus VC is equal to 0. And if you differentiate this again, you're going to have this relationship AA plus 2 times of AB and minus AC is equal to 0. This is an extremely important relationship. Okay, fine. Now let's go ahead and let's work out the motion analysis for all the 3 blocks separately. So here we go. Okay, first of all, let me write this. Where can I write this? AA plus 2 times of AB minus AC is equal to 0. This is an extremely important relationship and we're going to be using it to compute the final value of tension T. Alright, so here we go. Over here, how much was the force? I need to see that once again. And over here also. How much was it? 600 and that's 800. Okay. 600 and that's 800. That's NA. So when the blocks are moving, tension, let's assume it to be T. Okay. And since this block is going to go downwards, down the plane with an acceleration AA, let's say, so the friction will act along this direction. Let's say that friction at block A is equal to how much? How much did we calculate? This worked out as, let me check how much it is. I guess this was 160. 160. Where is the friction? Where is the friction? Yeah. 160 newtons. Okay. Immediately. Summation of all the forces, x direction, mass, acceleration, block A. So that's x and that's y, right? So this is where the motion is happening, down the plane. What is the force acting along this direction? 600. Take it as positive, and all the forces opposite to this force, take it in the negative sense. So we have this equation, 600 minus T minus 160 is equal to mass. How much is the mass? We don't know. We know what the weight is. So weight divided by G, that is 9.81, will give you the mass. So you need to write 1000 over G multiplied by AA. So let me change this equation slightly. AA will be equal to 600 minus 160 is how much? This is 440 if I'm not wrong. Let me check. Yes, it's 440. 440 minus T over 1000, right, multiplied by G. So that's the acceleration A that we've got from this Fx is equal to ma equation. Now, as far as block B is concerned, the tension over here is T. So totality, the tension over here is 2T, right? So we are assuming block B moving in the downward direction, AB, and this is how much block B's weight is, 800. Right, that's it. So this is where the motion is happening downwards. What is the force in the downward direction? It's 800. Take it as positive and take this 2T. Since it is opposite to the direction, take it as negative. So again, summation of all the forces in y direction, mass, acceleration for block B, we have this B as the subscript, right? So it's going to be very simple. 800. Now this is y direction, okay? That's x. So none of the forces are along x direction, so analysis along x direction is not to be carried out, don't worry. So 800 minus 2t is equal to mass into acceleration. Mass is going to be weight, that is 800, okay, over g multiplied by AB. So AB will work out as 800 minus 2t over 800, all of this multiplied with g. Okay, let's work out the forces acting on this block C, right? First of all, we have this as the normal at C, and it's gonna have a component here and here. But first of all, weight acting in the downward direction. How much is the weight? See, it's 400 newtons. 400 newtons. So it's going to have a component here. So this is nothing but 36.87, same theta. Okay, so here the component will be 400 cos 36.87, and here the component will be 400 sine 36.87. I just need to work this out, how much this is in a calculator. 400 cos 36.87, and this is working out as 320, right? 320 newtons, and this over here will work out as 240 newtons approximately, right? Okay, and secondly, we have this tension T. Okay, fine. Since this block C is moving in the upward direction, uphill, with an acceleration of AC, the friction acting will be somewhere along this direction. Okay, this way. And as far as this friction is concerned, this friction is on block C is equal to coefficient of friction, that is 0.2, multiplied by the normal. This normal will be equal to this force over here, that is 320. So 3 into 320. So 0.2 multiplied by 320 will give us 64 newtons. So that's the friction force applied, 64 newtons. That's it. Now again, the same stuff. You need to apply motion equation. Summation of all the forces in X is equal to product of mass, acceleration, block C. So this is the X direction and this is the Y direction. Okay, now you can clearly see block C is moving uphill and T is also uphill. This has to be taken as positive, and this 240 newtons and this 64 newton, both of them will be taken in the negative sense, since they're acting opposite to the direction of motion. That's why. So let's write this: T minus 240 minus 64 is equal to what? Mass. How much is the mass? We don't know what the mass is. We know what the weight is, 400. So weight is 400, and that divided by g will give you the mass, multiplied by acceleration AC, and you just need to solve this. T minus, this is going to work out as 304 if I'm not wrong. Let me check how much it is. 304, yeah, is into g over 400. This is precisely the expression for acceleration C, or acceleration of block C in terms of T, right? Okay, we are going to put all of this into this equation, right? So we have the value of AA. Let me write this over here again. AA plus 2AB minus AC is equal to 0. So how much is AA? This much. So G can essentially be taken as common from all of them. G, G and G. Alright, so it's going to be 440 minus T over 1000. Done. What's next? Then we have again plus sign, twice of this 800 minus 2t over 800 minus 2t over 800. Then finally we have a negative sign, this negative sign you can see, minus of AC. How much is AC? It's t minus 304 over 400. T minus 304 over 400, and all of this is equal to 0. Now guys, it's very simple. One equation, one variable. That variable is t. You just need to solve for t, and t will work out as, let me check how much it is. This is going to work out as 376.4 approximately. And when you put the value of t over here, here and here, you're going to get the individual accelerations of all the three blocks, that is A, B and C. And let me write their values. AA will work out as 0.62 meters per second square. AB will work out as let me check, 0.58 again meters per second square. And finally AC will work out as 1.77 meters per second square. Okay, now you can clearly see that the value of AB that we've got is positive. That means the direction that we chose, this way, downward, was absolutely correct. So guys, that was all from my side for today. If you've got any doubt or query, do write them down in the comment section below. I'll be very happy to answer them. And if you believe that this video tutorial has added value to your knowledge of engineering mechanics, then do share and like this video, subscribe to this channel, and also press the bell icon so that whenever I upload a new video, you get a notification, you get an update. Well, do tell your friends about this channel so that they can also benefit. I'm going to be back with more such videos on drawing and mechanics. Until then, it's a wrap. This is Manas Patnaik signing off. Take care, have a great day, and keep learning.